Hello friends, I welcome you in lecture number 3 on gamma distribution. In lecture number 1 and 2, we have introduced gamma distribution and we have also discussed what are the mean and variance of gamma distribution. So I suggest you to watch lecture number 1 and 2 first before going for this lecture. From this lecture onwards, we will discuss GTU exam questions related to gamma distribution. And in this lecture, we have tried to solve this question on gamma distribution which was asked in GTU Winter 2020 exam. First we understand this question and then we will see how to solve it. In a certain city, the daily consumption of electric power in millions of kilowatt hours can be treated as a random variable having a gamma distribution with parameters alpha equal to 2 and beta equal to 3. So here we are already given that this is the problem of gamma distribution. It is given that the daily consumption of electric power is a gamma random variable and parameters are also given. So here we don't have to decide that which distribution is suitable for our question. It is already given that we have to use gamma distribution. So all we have to do is we have to remember the PDF of gamma distribution and we are given values of parameters also. If the power plant of this city has a daily capacity of 12 million kilowatt hours, what is the probability that this power supply will be inadequate on any given day? And we are asked to find the mean of this probability density function also. So first we understand this line. If the power plant of this city has a daily capacity of 12 million kilowatt hours, that means daily capacity is 12 million kilowatt hours, and if daily consumption is exceeding this 12 million kilowatt hours, then power supply will be inadequate, because it is given that power plant of this city has a daily capacity of 12 million kilowatt hours. That means power plant can provide 12 million kilowatt hours electric power in a day, and here we are asked to find the probability that this power supply will be inadequate on any given day. And daily capacity or daily power supply, maximum daily power supply by this plant is 12 million kilowatt hours. This plant cannot provide more than 12 million kilowatt hours electric power in a day. So power supply will be inadequate if the consumption will exceed this value 12. So if the requirement of electric power is greater than 12, or if requirement exceeds 12 million kilowatt hours, then power supply will be inadequate on any given day, because the capacity of power plant is 12 million kilowatt hours on any given day. And here it is already given that random variable is the daily consumption of electric power. So this is our random variable capital X, and it is already given that X is a gamma random variable, and we are asked to find the probability that power supply will be inadequate on any given day. So if this daily consumption, which is denoted by capital X, is greater than 12, then power supply will be inadequate on any given day. That means we have to decide the probability that capital X is bigger than 12, where capital X is the daily consumption of electric power in millions of kilowatt hours. Now it is given that X is a random variable with parameters alpha equal to 2 and beta equal to 3, and to obtain this probability we will require probability density function. By the definition, this is nothing but integral from 12 to infinity integral of probability density function of gamma distribution with respect to x. So we have to obtain this integral. Now what is PDF of gamma distribution? And we have already discussed all these things in lecture number 1 and 2. If we are using parameters alpha and beta, then PDF is 1 over beta raised to alpha times gamma alpha x raised to alpha minus 1 e raised to minus x divided by beta whenever x is positive, otherwise 0. So we have to put values of alpha and beta, which are given as alpha equal to 2 and beta equal to 3. So we will put these two values in fx, and whatever function we obtain, that we will integrate from 12 to infinity. So this is very simple question. You have to just remember PDF of gamma random variable, and it is already given that this problem is of gamma distribution. Our random variable, the daily consumption in millions of kilowatt hours, is given as gamma random variable. So we have to just put values of alpha and beta in the PDF of gamma random variable, and then we have to integrate this PDF from 12 to infinity to obtain required probability. I have written all these things systematically. First, I have written this PDF of gamma distribution, which we must remember for this problem, and I have started. First, I denote this daily consumption of electric power, which is our random variable. So we denote this by capital X. Capital X denote the random variable, which is the daily consumption of electric power in millions of kilowatt hours. It is given that X is a random variable. It is a gamma random variable with parameters alpha equal to 2 and beta equal to 3. And this is what I just explained. Since the power plant of the city has a daily capacity of 12 million kilowatt hours, the power supply will be inadequate if the daily consumption of electric power, that is capital X, exceeds 12 million kilowatt hours. Power plant can provide 12 million kilowatt hours daily. That is the maximum supply by power plant, because its capacity is 12 million kilowatt hours. So power supply will be inadequate if our random variable X exceeds 12. So required probability that the power supply will be inadequate on any given day will be equal to probability that capital X is greater than 12, and that is by definition of PDF given by integral of fx from 12 to infinity. And then I have written PDF of gamma distribution, and in this formula we consider alpha equal to 2 and beta equal to 3, and we have 1 over beta is 3. So 3 raised to 2 gamma alpha, that is gamma 2. Here I will have x raised to 2 minus 1 and e raised to minus x divided by 3. And our range of integral is from 12 to infinity. So we will consider this x positive. We will consider value of fx as this part, because fx is given by this formula if x is positive, and we have to integrate from 12 to infinity, so x is positive. So we will consider this portion. So I have put values of alpha and beta in this formula, and I obtain this function. Gamma 2 is nothing but, we know that if n is integer, then gamma n plus 1 is n factorial. So gamma 2, that is gamma 1 plus 1, and by this formula it is 1 factorial, that is 1. Gamma 2 is 1, 3 raised to 2 is 9, x raised to 2 minus 1, that is x, e raised to minus x by 3 whenever x is positive. So we have to integrate this 1 by 9 times x e raised to minus x by 3. We will put that value here, 1 by 9 x e raised to minus x by 3. So required probability is integral of fx from 12 to infinity. We replace fx by this now, Now this is simple problem of integral. Here we have to apply integral by parts. If we have product of two functions, we know that we keep first function as it is, integral of second function, derivative of first function, integral of second function, integral of v is denoted by v1, derivative of u is denoted by u dash. Then integral of v1 is denoted by v2 and derivative of u dash, that is u double dash, and so on. And alternately positive and negative sign, we consider that function as u whose derivative is 0 after some finite number of steps. So here the choice for u is x and this is v. So I have used this formula. 1 by 9 outside, it is independent of x. Then x as it is, integral of e raised to minus x by 3 is e raised to minus x by 3 divided by coefficient of x, which is minus 1 by 3, minus derivative of x, which is 1, integral of this bracket, so minus 1 by 3, integral of e raised to minus x by 3 is again e raised to minus x by 3 divided by minus 1 by 3, and there is already 1 minus 1 by 3 in the product, so we will obtain 1 by 9. In the next step, derivative of 1 will be 0, so we have only two terms. Now I have simplified all these things. I take minus 1 by 3 in the numerator and I will have minus 3x. Similarly here I will have 9 and I can take e raised to minus x by 3 common. So I obtain this term minus 3x minus 9 e raised to minus x by 3. Limits are from 12 to infinity. In the next step I have taken minus 3 common here and I obtain x plus 3 times e raised to minus x by 3. I take minus 3 outside this, it is independent of x, so that 3 will cancel out with this 3 and I have minus 1 by 3. This I have rewritten as 1 over e raised to x by 3. Now first I have to consider limit of this function as x tending to infinity, and then I have to put x equal to 12. So that I have written in this way, value of this function as x tending to infinity, so that I have written in the form of limit, that limit of x plus 3 over e raised to x by 3 as x tending to infinity minus x equal to 12, that is 12 plus 3 divided by e raised to 12 by 3, that is e raised to 4. Now this is a limit as x tending to infinity, and if we check that x plus 3 becomes infinity if we take x tending to infinity. Similarly e raised to x by 3 becomes infinity if we take x tending to infinity. So this is infinity by infinity form, this is indeterminate form, infinity by infinity. Therefore we can apply L'Hospital rule. So in the next step we take derivative of x plus 3 and e raised to x by 3 separately. Derivative of x plus 3 is 1, derivative of e raised to x by 3 is e raised to x by 3 into coefficient of x, which is 1 by 3. So that I have written here. Derivative of x plus 3 1, derivative of e raised to x by 3, which is 1 by 3 e raised to x by 3. So that I have applied L'Hospital rule, and this becomes 15 divided by e raised to 4. Now if we take x tending to infinity in this term, we will have 1 over 1 by 3 e raised to infinity by 3, that is e raised to infinity, and this becomes 3 divided by e raised to infinity. E raised to infinity is infinity, so we have 3 over infinity, that becomes 0. So in the next step this is 0 minus 15 divided by e raised to 4, that is, now we can multiply this, minus 1 by 3 times minus 15 divided by e raised to 4. So this 3 will cancel out, negative negative positive, and 5 divided by e to the power 4, and if we use scientific calculator we obtain this answer up to 6 decimal places. This is 0.091578. So this is the required probability. Probability that daily consumption exceeds 12 is 0.091, and if we further wish our answer up to 3 decimal places, then here I have to write 0.092. So this is the required probability that power supply will be inadequate on any given day is 0.092 or 5 divided by e raised to 4. And we are asked to find out mean of distribution also. We have discussed mean and variance of gamma distribution in second lecture. We have obtained the formula for mean and variance, and now we are familiar that mean of gamma distribution with parameters alpha and beta is given by product of alpha and beta. Here alpha is given as 2, beta is 3, so mean of given distribution is 6. So in this way we can find out probabilities related to gamma distribution. This question becomes very easy because it is mentioned that your problem is of gamma distribution. You are already given that you have to apply gamma distribution. Your random variable follows a gamma distribution. So all you have to remember is formula for PDF of gamma distribution, and you have to just understand this probability, what is the required probability, and you can easily answer this type of questions. So this is all about this session. In upcoming sessions we will be discussing GTU exam questions related to gamma distribution. Thanks for watching.